The purpose of the study analyzed in this video is to determine how to inhibit the transport of E. coli in the environment. E. coli, particularly the 0157H7 strain, is a bacterium that causes approximately 73,000 gastrointestinal infections in humans annually and can result in death. One way of preventing outbreaks of E. coli is using biofilters like biochar to inhibit the transport of the bacteria in the environment. Biochar is a carbon-rich porous material that is produced by burning biomass and organic material in a low-oxygen environment. In the article for this study, researchers tested many different variables for biochar to see which one out of 8 different options is best for filtering E. coli. The first variable is pyrolysis temperature, which is either 350 or 600 degrees Celsius. The second variable is biochar type, which is either pine bark or pine wood. The third variable is oxidation state, in other words, whether the biochar is oxidized or unoxidized. The final variable is electric conductivity, which is a measurement of how easily a material allows electric current to flow through it. For each of these 8 biochars, breakthrough curves were plotted for pore volume versus bacterial concentration ratios, which are the ratios between effluent concentration and influent concentration. The lower the effluent concentration compared to the influent concentration, the greater the retention of E. coli in the porous media, meaning that the lower the values are on the breakthrough curves, the better the biochar inhibits the transport of E. coli. Based on this logic, the most favorable data points belong to the biochar breakthrough curve at the bottom in green. This particular biochar was heated at 350 degrees Celsius, is pine wood, and is unoxidized. The research questions for this dataset are whether each of these 4 variables by themselves affect E. coli transport. To answer these questions, breakthrough curve plots and box plots were used to see the differences between each of the variables' values, and ANOVA tests were performed. For pyrolysis temperature, the plots show that there is a difference between having the biochar heated at 350 degrees Celsius versus 600, since the median for 350 degrees is lower than for 600 degrees on the box plot. However, upon performing an ANOVA test, it was determined that there is only a 7.7% chance that there is a relationship between pyrolysis temperature and bacterial concentration ratio, indicating that most likely there is no pyrolysis temperature that is favorable over the other when it comes to inhibiting E. coli transport. When looking at the plots for biochar type, it appears that the bacterial concentration ratios for pine wood are significantly smaller than the values for pine bark. This statement is further supported by an ANOVA test, which calculated a 99.786% chance that there is a relationship between biochar type and bacterial concentration ratio. Therefore, pine wood is more effective as a biofilter than pine bark. Based on the box plots for oxidation state, E. coli transport appears to be strongly affected by oxidation state, since there is an obvious difference between the values for oxidized versus unoxidized biochar. This statement is further supported by the ANOVA test performed, since the p-value is calculated to be 2e to the negative 16, indicating that there is a 2e to the negative 14% chance that the null hypothesis is true. The null hypothesis is that there is no relationship between oxidation state and bacterial concentration ratio. Therefore, there is almost a 100% chance that there is a relationship between oxidation state and bacterial concentration ratio, and unoxidized biochar is definitely more suitable than oxidized biochar as a biofilter for the bacteria. The same p-value calculated for oxidation state was calculated for electric conductivity, indicating that there is almost a 100% chance that there is a relationship between electric conductivity and bacterial concentration ratio. Therefore, lower electric conductivities are better for inhibiting E. coli transport in the environment. In conclusion, the only variable that does not have an impact on E. coli transport is pyrolysis temperature. This is likely because up to a certain temperature, the difference in temperature becomes negligible in terms of biochar effectiveness as a biofilter. The variable with the greatest impact that can be seen both visually and quantitatively is oxidation state. This is likely due to the fact that an oxidized biochar that has not reacted with oxygen is less likely to have E. coli moving through the biochar, since the bacterium is less capable of growing in areas without oxygen than they are with oxygen. However, to determine the exact reason for these results, more research needs to be done. Thank you for watching and listening to this presentation.